So if we continue the same example with the beam, but now with first order reliability method form, the beginning is similar with the limit state function as before. In form, we want to write this in variables x1, x2, x3, and x4. The variables are, as before, described by normal distributions for the section modulus, log normal for the yield strength, and here calculating the log normal standard deviation and log normal mean. The Gumbel distribution with the mean and standard deviation, which gives the following a and b values, and the length with the mean value and standard deviation as we have described before. We now need to transfer these into a failure function described in uroom, and we have now inserted the transferred version of the parameters as follows. And you recognize the section modulus, the yield strength, the loading as Gumbel distributed, the length squared divided by 8. Then we have a program in MATCAD that is iterating a solution for the beta value, finding a solution where distance between the origin and the failure surface is minimized. And after the program has done its work, this is the result we are getting. Well, the first estimate of beta was 3.68, and then we can see that it's iterating its way to 3.175. So here we have the first values we have is the alphas, then we have the A values, then we have the lambda, and then we have the design point for the U values that is calculated. Based on the beta value, we can of course calculate the probability of limit state exceedance, and we are getting values similar to those we have found in the Monte Carlo simulation. The very interesting thing we can do when we are doing a form analysis is to use the U values that we have defined, see how the design point with this probability of limit state exceedance looks like. And here we see these are the design points in U room. We might also need the normal to the failure surface for these points. And we can calculate the design points in the X room by doing the reverse transfer from U room to the X room. And we are getting the design value for the section modulus, for the yield strength, for the load, and for the length. And this can, for example, be used. We have found that the limit state exceedance that we have calculated is acceptable. We can use this to calculate suitable load factor for the ratio between the design value and the characteristic value. And in this case, we know that the characteristic value was 4.88, and we can calculate a suggestion for the load factor by the ratio between the design point value and the characteristic value. And the suggested value here is 1.33, which is a reasonable value for a load factor.